Hello everyone, here are the answers to the multiple choice AP practice problems I assigned yesterday. So give these another try if you missed any. For Monday, I will have these worked out for you. Part of your assignment today is still to continue on that Chicago free response question number 6 on Monday. In that video lesson, I will go over that one as well. All right, let's see what you were coming up with for the integral of cosine square x dx. Now what we could use, since we now know what the integral of sine square x dx is, let's go ahead and see if that's going to help. So let's recall that the integral of sine square x dx became a couple ways to write this. 1/2 x minus 1/4 sine of 2x plus c. So we could use this now. We could go back and try to look at the cosine square x, so that might be helpful. Or we could just use this right here. So we could write this as the integral of 1 minus sine square x dx. And then we could just take the, or replace the sine square x with what this is going to become if we separate the integrals. So here we're going to get the integral of 1 dx minus the integral of sine square x dx. So this will just give us x minus this quantity that's over here. So minus a 1/2 x plus 1/4 sine of 2x plus c. And then we can combine these two. So we'll just get a 1/2 x plus 1/4 sine of 2x plus c. Now if you check this on your calculator just took this identity of sine 2x, so this becomes 1/2 x, and if you recall, sine of 2x is equal to 2 sine x cosine x. So taking a fourth of that, that will just turn into 1/2 sine x cosine x plus c. So this is acceptable, so is this. Or another way to look at this is if we didn't use the sine square x integral, we could start with the same way we took care of the integral of sine square x. We would have cosine of 2x was equal to 2 cosine square x minus 1. So if we add 1, we'll get cosine 2x plus 1 is equal to 2 cosine square x. We could solve this for cosine square x. So that's just going to equal 1/2 cosine 2x plus 1/2. So now the integral of cosine square x dx becomes the integral, just put the 1/2 first, 1/2 plus 1/2 cosine of 2x dx. Now we take the antiderivative of each term, so we're going to get 1/2 plus 1/2 times sine, but we'll have a 1/2, and then we'll have sine of 2x plus c. So we get 1/2 plus 1/4 sine of 2x plus c. A little bit quicker that way, but again, we can compare. We ended up with that right here as well. So two identities that could have helped us. All right, we're going to start section 6.2 today. We're going to spend a few days on this, and it's an integration technique. It's called U substitution. And this is going to help us evaluate more difficult indefinite integrals. Now, normally what we would try to do is simplify the expression, or if, say, this was a quantity squared or a quantity cubed, we could actually expand it to see the individual terms. We definitely don't want to do that here. So this little technique, again, called U substitution, we let U represent a larger quantity, so we're taking like a binomial and turning it into a monomial. So we're going to let U equal what's inside the parentheses here. But if we're using a U, we can't have a dx. We need to have a du. So what I'm going to do is take the derivative of both sides, or take the derivative of u with respect to x. So we're going to say du over dx take the derivative of the right side, which is just going to be 1. And then I want to solve for dx. So if I multiply both sides by it, we just get du is equal to dx. So now we substitute. So now this becomes u to the 8th instead of the quantity to the 8th, and dx just gets replaced with du. And now I could take the antiderivative of this. This will give me u to the 9th over 9 plus c. But we can't leave u in our final answer, so we just bring back what we let u equal to begin with. So now this is the quantity x plus 2 to the 9th over 9 plus c. Now sometimes u substitution isn't necessary. We may have been able to reason through this one, but chances are, like if there happened to be a chain rule in effect when, say there was a coefficient in front of that x, u substitution is definitely more helpful that way. But that would be the antiderivative for our very first example using u substitution. Let's take a look at another one. Now when that dx is in the numerator, we could just simply rewrite this. This is really the integral of 1 over the quantity 5x minus 2 cubed, and then the dx is after it. So just like in the last problem, let's let u equal the 5x minus 2. And then du over dx is just going to equal 5. Well, again, we want to solve this for dx. I'm going to multiply both sides by dx. I get a 5 dx. And then divide by 5. So du over 5 is going to equal dx. So now this becomes the integral of 1 over u cubed, and dx is du over 5. Well, I could take this 1/5, that's just a constant, and I could move it out in front. I could also rewrite this as u to the negative third du, and now I can apply the power rule. So this becomes 1/5 times u to the negative second over negative 2 plus c. I could still pull the negative 2 out, so I'm going to get a negative 1/10, and really times 1 over u squared plus c. And now we're going to bring back the 5x minus 2. So this is definitely where u substitution is helpful. We would not be able to reason through this too nicely. So we're going to get a negative 1 over, we just put the 10 down here, and then it's going to be the quantity 5x minus 2 squared plus c. Now remember, you can always check this. If you were to take the derivative of this expression and then you end up with 1 over the quantity 5x minus 2 cubed, you know you're doing this right. Another example. Again, we can rewrite this as the integral of 1 over cosine square of 4x dx. Now let's try u substitution, and usually it's just the quantity that's right here, so we're just going to let u equal 4x, and then du over dx is just going to equal 4, and I can switch those around, so du over 4 is equal to dx. So now I'm going to get the integral of 1 over cosine square u, and then we'll have du over 4. So I'm going to pull the 1/4 out, and then we have 1 over cosine square u times du. Now I know we took the integral of cosine square x. That's not this case. So here we actually want to use a trig identity, and the reciprocal of this is just going to become secant square u. And that should be pretty helpful. What we're trying to think here is what trig function, when we take the derivative of, will give us secant square u. And hopefully you're thinking tangent. So this becomes 1/4 tangent u plus c. And then we just bring the u equals the 4x back. So it's 1/4 tangent of 4x plus c. Let's try another one here. Again, we could start rewriting this as 1 over the integral of 1 over 3x minus 1 dx. So again, with this one, follow this the sort of the same setup here. We'll let u equal to 3x minus 1. du over dx is going to equal 3. So du over 3 will equal dx. So now this becomes the integral of 1 over u times du over 3. We'll move that 1/3 out in front. We get 1 over u du. I want you to carefully think about this. Can we use the power rule for antiderivatives here, or is it another function that we have to think of in reverse? And it's the latter of what I just mentioned here. We can't say this is u to the -1 because if we follow the power rule, we'll get a 0 in our denominator. We can't have that. So what's the antiderivative of 1 over u, or in most cases 1 over x? Should be the natural log. So it's 1/3 times the natural log of the absolute value of u plus c. So now this becomes 1/3 times the natural log of the absolute value of 3x minus 1 plus c. All right, so here's your assignment on pages 321 to 322. Please do this set of problems. Make sure you correct the AP problems. Like I said, I will have the solutions worked out in the lesson, the video lesson for Monday. Also go back to pages 312 and 314. Try numbers 42 and 58. Continue working on that free response question I assigned on Wednesday. And then probably by next Thursday, I want to give you guys time to do test corrections. We'll have a quiz over 6.1, a little of 6.2, and definitely some problems from the Chapter 5 test. Please let me know if you have any questions.